Okay, so as far as installation is concerned, how do you install? Pip install TensorFlow. That should install 1.4 version of it. Then it will have TensorBoard and every dependency in it, so you don't have to do anything. Later on, you have to install Keras also. Okay, TF install Keras so that all the Keras related packages, sub packages, everything gets installed. So two things are there. One is TensorFlow and one is Keras.
Both of them has 32-bit version because my laptop is a 32-bit.
Yes. Now, in one of the previous batches, one student has done it, but for that he had to do something. Maybe he found the answer in Stack Overflow. If you have 32-bit version, right? It won't be direct.
Okay.
Okay, there is you tell your system that it is, you fake your system that it is not 32-bit thing. Then only it happens actually. Okay, but anyway, you can use Google Cloud. Sorry, not this guy, this Collaboratory, or you can use your AWS Cloud and right?
Okay,
Because it might mess up with few other things.
So you need to I install Anaconda in the I collab itself.
Collab you don't have to install anything. You can right now create a Collab account.
Oh, so by default it will have TensorFlow.
Right, everything it will have. I'll use it by default. I will show. Okay, so now let's see. Okay, so now let's understand what is TensorFlow. Okay, as you can see. Okay, as you can see here, it is one of the machine learning library that is by Google. Okay, numerical computation library using data flow graph. Let's understand what is TensorFlow. Does not provide anything special. If you're coming from Python background, or you might have heard about NumPy, right? NumPy is nothing but numerical computation library. TensorFlow is alternative to NumPy. Okay, TensorFlow is alternative to NumPy. So, I mean, it just provide you mathematical computation library and something that can be parallelized and made fast. Right, that is the whole and soul logic out of it. So, as you can see here, you have this as, I mean, suppose what you want to do is sum of two data. This, imagine this is A and this is B. You want to do A plus B plus A into B. Understood, right? That's the whole maths you intend to do. A plus B plus A into B. If you have to represent such thing in data flow graph, this is what data flow. See, remember, understand this concept of data flow graph is, something something very popular in terms of distributed computing. Okay, if you might have heard about Spark, right? Yeah, there also it uses the same concept for doing computation. Okay, so what it does here, what is the mathematics operation you intend to do? A plus B plus A into B. For that, it is actually breaking that up into this graph. This is A, this is B. Okay, this what are you doing here? A and B. This is okay. This is A and B. This is your multiplication operator. This is your addition operator. So see what you are doing. You are passing your A is going, B is going. You're doing an add operation. Your A is going, B are doing multiplication operation, and you are actually the output of this goes as an input of this, and you're doing add operation again. Understood, right? So what is happening? This is how you have a simple mathematical operation: A plus B into A into B, right? And this is how that get translated into. Okay, so what will TensorFlow do? No matter what complex, see, machine learning is nothing but internet is pure maths, right? Right. So whatever you do, whatever you intend to do, it will eventually convert it into graph. This is known as tensor. We can see this when it generates a data like graph like this, right? We're using TensorBoard, we will be able to see this. And when you proceed further, just by seeing the graph, we should be able to tell, okay, this graph is generated is correct or not correct.
You can
Optimize the graph. You can see, you can debug through the graph. These TensorFlow graphs are pretty powerful, and this is one of the important feature of TensorFlow among from all its competitors. Okay, this graph based this graph, right, makes it, enables it to do distributed computation. Okay, how? What happens? This part can be this part can be handled in one machine, isn't it? Whatever you are seeing me, this part.
So input to the multiplication.
So this part, sorry, this part can be handled in one machine. This part can be handled in another machine. Understood, right? And
right.
and the output of this can come to another machine. So this distributed graphs, okay, are can handle distributed computing by default.
So here you put additional multiplication, like that can do
All sort of stuff, complex, and a lot of mathematical operation it can do. So what is TensorFlow? TensorFlow is nothing but a mathematical computation library using data flow graphs. Okay. Now, if you have this foundation library, you obviously like how is, I mean, I'll just give a comparison to scikit-learn. Okay. In scikit-learn, all the libraries written using NumPy. If you see scikit-learn code, like in case you are hearing this new for so scikit-learn is a machine learning library for Python, and when you're using scikit-learn is written all using NumPy, right? Okay. Similarly, TensorFlow algorithms are written using TensorFlow, TensorFlow this way. Okay, as you might be already expecting, it is written in C++ mostly, and the wrapper is using Python. So that is how most of the machine learning libraries are. It is mostly written in C++, C++, and the wrapper around it is Python.
Oh.
Okay, then you have, so another important aspect of TensorFlow is you can train the model, save the model, train the model again, save the model again. Okay.
Train the model with different data.
Train the model with different data. So suppose you train the model, and the important part about TensorFlow and the reason why it getting a lot of popularity is you can train the model in Google Cloud. Okay, download the model in your Android phone, and your phone will do the prediction for you. For prediction, you don't need a lot of computation. For training the model, you need a lot of computation. So the training part of the model can be shifted to cloud. Understood, right? The training part of the model can be shifted to cloud, whereas prediction do not need a lot of computation. That can be handled. You might have heard about Google Lens and all this stuff, right? So you can, and you will periodically update your model. That's pretty much right. Right. So that is how it works. Okay, and that is how it gets a lot of popularity. TensorFlow can use as backend as Keras. Now it is official in in 1.4. Okay. Flex. Keras, no. Keras is no, from nowhere. It's open source.
So was that adopted here?
Of course, I mean, there will be few developers.
Okay.
Right. Right. Open source. If you want to check, you can check keras.io. Official website for Keras.
So this deep learning, like as you said, it takes computation training time, lot of time. Right. So here we are doing two work. So, but when we are in the case of machine learning,
Sure.
the training time is faster, but while testing the data, that takes more time.
Oh, which one?
Machine learning. So deep learning actually training time takes lot of time. When you really build the model and run it on the test actually, so that time it runs faster. But I think that is in machine learning, the training time is faster and test time.
Not, yeah, I mean, if you have to compare it this way, definitely deep learning takes more time to train deep learning models and more data to train, of course. More data to train with less data. Now there are a lot of research happening, a lot of things, a lot of ways are there by which less data you can do more training. Okay, but essentially the fundamental difference in deep learning takes more time to train. Okay, but the difference between machine learning and deep learning, if you do it right, is basically the accuracy. Okay, the prediction is not a big task. It does not take a lot of time, but the accuracy results. Okay, so for same thing, you might see better accuracy using deep learning compared to as far as images are concerned, as far as unstructured data is concerned. Okay, if you can solve something with machine, this is a common, if your problem statement is simple and you have less data, you better do machine learning. Okay, you cannot use a tank to kill a bird. Okay, so okay, so this is officially Keras. Have a look into it. Okay, as you can see here, Keras can in the backend use TensorFlow CNTK Thenios. Okay, it is using this. You can, I mean, I'll show you some very simple ways to write the code. You can see here what you're creating here. You're creating a deep learning model here, just 5 lines of code. So code writing has become really simplified. Okay, we'll write the TensorFlow low level code also to see how this neural network basically works, and we'll write with Keras, and it would look like something like this. Okay. Then coming to this point, you can run it on CPUs, you can run it on GPUs, right? And another important aspect is Google releases pre-trained models of TensorFlow, which for using that you can, for example, you have to open a startup. Okay, and recently this happened. Recently Zomato had a show the foods photo. It will tell you what it is and all that. Okay, recently Zomato was trying to integrate. I don't know if they're finished with that. Okay, so now there was a company which used these trained models from Google. Okay, and it trained more with food. Okay, so now this model is more specified in food related stuff. Okay, now they sold this thing to Zomato. Sold it.
Okay. No,
Like it was like 3-4 months effort. Okay, they did it and they sold it to Zomato.
Oh.
At a very initial stage, they just wanted to get some money out of it, fresh guys. Okay, so they sold it to Zomato. So Zomato is integrating, advancing it more, integrating with their uh, so that when people take photographs of food, that being a predominantly food website, they will give you possible tags, right? That means okay, this is paneer butter masala and all that, right? They will give you a tag.
But how it will recognize the food? So because we take the photo, so probably it will let us know all the ingredients in it are just
No, nothing like that. The way, see, how deep learning was basically the same way with our brain works. Okay, so if we can see a photo of paneer butter masala and identify this is paneer butter masala, it should be solvable by this deep learning. Okay, because this is same unstructured data. You have to train it with some paneer butter masala, of course, prior to that. And once that is done, it should be able to figure out. Okay, it should be able to figure out it will, like maybe in paneer definitely will send some white blocks of paneer, right? So humor things around the color of the, like you have some sweet like I think methi matar masala, methi matar paneer, that is really very yellowish in color, right? Yellowish in color. So that stuff is like, okay, this is paneer but yellow is this color combination, this it might be this, right? It don't show one result. Right, it might not show one result, it will show you multiple options. I have seen that stuff, because like it will show 3-4 options. Okay, then it is up to you to, like the way it happens in Google, in Gmail these days, or LinkedIn these days, right? And gives you few options. Okay, then you choose which one is that. Okay, that is what it will do. Okay, so make tagging little easier and uniform tagging. Right. I mean, what is the benefit out of here? Like everybody will give paneer butter. So, the training will be like after some times it will be good stuff. Right? So that was the model about. So it's, I mean, now the market is such that, I mean, if you are, see this just off the line of the record. So if anybody wants to get into AI based toys, it is a very good time now. If you develop, see, I mean, where this is where deep learning comes into picture. Okay, so if you create a toy that understands voice, and based on, if you say in the IoT device, you say go left, go right, it will go left, go right, right? So this is a very good time for, I don't know why none of maybe they're doing the work. Okay, but AI based toys, I mean, which understands human voice and behaves accordingly, right? Right, those sort of toys are and it will understand only your voice. So these all applications are very easy to develop using deep learning, right? Okay, okay. So earlier there were a lot of stable. I mean, this is a little older node, so a lot of stability with Python version and all. Now with latest version of Python, there is no issues with 1.10. Earlier, right, 1.3 was only fine with 3.6 version of Python, 3.5 version of Python. Okay, in Windows. Okay, now it is quite stabilized. So let's see. Okay, let's see some TensorFlow code. Okay, so I'll do something in collaboratory just to you can also try it out here. So first you do a file, new Python 3 notebook. Understood, right? New Python 3 notebook. Okay, so we can try opening account in here. So as it's loading. Okay, let's now write some import TensorFlow as TF.
The alias name is mandatory, is it? As TF.
No, not mandatory. Yeah, not mandatory.
But when you are calling some object in that, you need to mention that TF dot.
TF dot. Yeah. So what you have to do, either you import TensorFlow, then all the packages will be there. So every time you have to call this, so you will directly call this. That sort of thing. Input TensorFlow dot something you have to write. Big name, right? So NumPy you have NP, for TensorFlow you have TF.
So
Right.
this is how user dependent. You can give whatever the name.
Right. But generally, this is the case.
But if you want to import instead of importing others, import star or something.
Input star, if you do, it will import the entire TensorFlow library. You don't want that. You want only whatever, because it's a huge library, right? Or would you want a lot of things to be imported? Okay. You would basically want only things that interest you. So this is how you import TensorFlow. Okay. So now onwards, whatever you do with TensorFlow, it will be available with TF. Okay. So I'll rename the file as getting started. Okay, this is our.
Oh, you didn't give a drive path as well, not a location, the file path.
Location path?
So where this file needs to be saved?
It should be saved in your cloud account. Every time you open it, you'll find the list of the cloud files. Just tell him that I'm recording anyway. He is not able to reach, or how is it?
I think he have reached. Okay. We have you can accept.
Okay. So if you want to check the Python TF version, okay, you can do this. No problem. Okay. Okay, you can see the Python TensorFlow version it is showing up here. Shift enter is the way to. So you can also create an account and get started. You don't have to do any installation. Okay, I mean this is like cloud-based stuff. Feel free to use it. They want people to use it to become more popular. Okay, and
the TF dot the double underscore version you have written it or
no, I've written.
But to know the
version number, right? So it shows you that we are using the latest version. Okay. Double underscore is Python's way to say that this is internal.
Oh.
Okay, so anyway, I mean in Python, whenever you say double underscore, these are the variables that won't be available directly. This is
they are writing a function. They mention
double underscore means that it is internal to that actually double underscore. Okay. Okay, so let's create a constant variable. Okay, so this is how what I say is. I think this is how it allows me. So here you can write, okay, hello world in TensorFlow. Right, so this is again code here. Okay, this is what you can do. So h is equal to, I'm creating a constant variable. it should usually prompt actually, so that maybe my internet is okay. Okay, HW TF dot constant. Okay, so let's I'll just writing hello world program just to see how it works. Okay, so you have this H and W. These are your TensorFlow. Okay, vary constant. That means this value is fixed. It will be this only. Okay.
That means to the W you are assigning a word called world.
World, yeah, but it is different from. It is not yet assigned. Okay. It is not yet assigned here in this case. Nothing is assigned. See, TensorFlow believes in not believes in. It uses the concept of lazy execution. The execution of the code is delayed till you call a function run with it. Okay, till that time it will not execute this. So here you have created the variable. Initialization is done. I mean, assignment is done, but it is not yet executed. Just declaration part. Okay, if you want to, so even if you do this, it is not executed. You just are mentioning here execution has not yet happened.
But if it is lazy execution, if you write something wrong in the code,
It will not be telling you there. Only if you run it at the end, then only it will tell you there. Right.
it's not good for learners.
Huh? That's why initially learning it takes a little hit. Okay, it's not that smooth. I mean, that's why you have high level library. Okay, so you'll not know here, but when you find, so if I do this, right, HW, see, even now it will not run. Okay, it will just show you the object that is created out here. It will not show the output of it.
So what's the command you use to put it in there?
Shift enter.
Shift enter.
Shift enter, yeah.
To the next line.
Next line. Yeah. Okay, to execute that line and go to the next line actually. It seems a little slow. No, yeah, I'm writing it in cloud actually. Okay, you don't need, I mean, any installation. You can do it. Make use of this environment actually.
No need to have it. This is a free from Google. All the code you can write it and save it in the Google Drive.
Okay. Now, if you want to see all the, in this process, all the nodes are created now. If you see, compare it with the diagram that we are seeing, understanding. Okay, so it has created that. Okay, it has. If you can see here, it has created this chain here. Understood, right? It has created this chain here. Okay, but execution has not yet happened. Okay, to make the execution happen with tf dot, it's not connected.
It's lost.
Oh, connect. Yeah, maybe that. See here, you have to do connecting.
Okay.
Initializing, connected. Yeah. Okay. So let me execute all of them first. Run all.
Oh. One after one.
You can see this. When I do HW, this output is coming here.
Oh, it's saying there it's a what's a data type.
What's the data type? Yeah. But it is not showing you the output. Okay. To see the output with say tf dot tab.
Yeah.
Okay. Then session. See, what is this session variable? It creates a session in which it will execute this guy. Right? I mean, you created the nodes, but you have to execute it. So that's why you have to create a session. Okay. Ses. Okay. Res is equal to dot run. Okay. This is what you need here actually. You need to run, you have to create a session in this entire graph. So till now, what have you done? You have created a graph. Understood, right? How would this graph look like? You have two data, two constant, and one way you have addition operation, like which will be, let's say, appending the data, right? At the end of it, it will be an output. So if you do a run and then you do pass HW, okay, and then you pass HW.
So we can run multiple sessions in the same.
Yes, of course, of course. See, now it is hello world. Okay, so see what happened here. So you have H and W. You have your HW. Three variables are there: HW and HW. HW is dependent on W. So you just, when you have to execute a code, you just call the last thing. It will do dependency management by itself. It will go back, solve all the dependency, then finally get you the output.
Even now it does.
Exactly. It is same through.
So is the same code which we'll be writing when we write it in Spider or Python?
Same code.
There's no syntax.
Nothing different.
So when we write in data set, it's not this complex.
Huh?
Because we select the code, for example, the HTML output, I select 8, 9, 10, 11 rows, and I do control enter, or I do run. So it will give me the output. I will not write like session in the, even in Python, I'm saying.
Even Python, you don't have to. So here, see, now you saw a concept of, this is known as lazy execution. Now the question that is there in your mind, what is the benefit of it? I mean, you're doing something difficult, right? There has to be some quantified benefit out of it, right?
Calling a session and then we are.
I mean, it's like, trying to get hold of your ear the opposite way, right? So what is the benefit out here? Okay, this lazy execution, and this is let's set optimize, and see, when you might write a lot of code here. Okay, you might write, so this code is not executed at each line. Okay, you have to create a session and finally call the code. Then what happened? Then it goes back in a dependency curve, finds what all is required, does some optimization itself. Understood? If you take care of execution, the execution responsibilities, performance is up to you. Okay, if you let TensorFlow to decide the best way to optimize the code, then you have to find now I am done writing the code, now you optimize it. Okay,
but it does it internally.
It does it internally. It will do all optimization for you.
Even if I write unnecessary code,
you'll get rid of it. It will not be executed.
But we will not be knowing. Right?
It will not be knowing. That's why.
But you have said before, we can see the path, how we can.
That all you can see. We can see the graph, that all it generates, and all that. That all we can see.
But from that we can't identify.
We can identify this is the this is the internal it is generating. This is what it is doing. We can see that. But code wise, we won't be able to see that. I mean, we will see that from that way we won't be able to see.
So here it is, even though it is so since we declare as a constant, so that's what it is coming as a, because 2 are the string variable, right?
Right.
Okay, so if you don't declare as a constant.
No, there are other things also, like you can declare them as a variable, you can declare them as a placeholder. There are other concepts. Okay, constant is like a constant. I mean, it is understood that you won't be changing it actually.
Okay, so even if you put h.w, what will be the output?
HW. This is dot here.
Dot. So is there a multiplication? So here we are doing.
No, there is string multiplication. Not. Okay, so this is H and W are your TensorFlow objects. Right? These are known as tensors actually. H and W are known as tensors, and of course you can do a plus operations between two tensors which holds string.
So tensor can be anything. It can be constant.
It can be variable, and they will see that. Okay, it can be variable. It can be constant. Right. It can be your this guy. Third option is it can be your placeholder. Okay, placeholder is when you're putting data from outside, that becomes a placeholder. Variable means something which actually changes itself continuously. You can see that. Okay, so we'll see much. Okay.
So there is a D prefix. B.
B is just the text representation. I mean, it is sometimes in Unicode. Yeah, U. So B is another way of nothing useful. It's just text.
Okay.
String representation based on this notebook. It has nothing to do with TensorFlow. Okay, string representation. Okay, so now we'll understand text, graphs, sessions, and fetches.
Put a comment is hash, right?
No, just click on the text part.
Comment.
Oh, comment is hash, same as Python. Okay. Okay, so let's create some. We have 3 constant values, A, B, and C. Right? Okay. Now, what you intend to do, you want to introduce some complex operation. D will be multiplication of A and B. Okay, we'll see graphs also shortly. Okay. D is multiplication of A and B. C is addition of B and C. F is subtraction of D and D from E. Understood, right? You have created dependency here. Okay. Now, if you do with tf dot with tf, then we inside this, right, with tf session, whatever code you write, that will be within that session. I mean, you don't have to yeah, exactly. You don't have to do anything here. Here, if you do out is equal to dot run, this is the way you execute it, and pass on a variable name. Pass on a variable name. Okay, if you do out, and in case you want to see the right text, print. Understood, right? So now you will not see anything with respect. Okay, so one thing you understand, what is this creating here? This is creating a graph for you. Graph. What is graph? We saw the diagram. This is graph. Oh, this is creating a graph for you. Okay, what you want to do is you want to actually see. I mean, if you want to see the default graph or access the default graph, okay, here by default it is getting added to default graph. So if you do tf dot get default graph, you can see get default. It will give you address of default graph object. Okay, so in case you are asking, right, you have to create multiple session, you might have to create multiple graphs. Understood, right? So in an application program, and okay, what is good if you create multiple graphs and both these graphs can be executed in different machines because they're totally independent of each other. Distributed, totally independent of each other. Sorry. Okay, you can see the address. Okay, this comes very handy when you're debugging it. It tells you that this particular information is associated with graph this because this is the default graph. If you want to create a new graph and associate everything with it, so G is equal to tf dot graph. It will create a new graph which is not the default graph. Okay. And how do you?
Is the default graph?
Yeah, no. This G is a new graph. See, the address is different. This is the default graph, and whatever you did so far, it gets added to the default graph. Understand, this is a big problem sometimes because if you keep writing code in the notebook, all your data is getting to the default graph. So a variable that you used earlier for some other execution can be in the default. Keep in mind. Okay, because we'll write a lot of code in notebook, so many times you'll feel that you're using the same notebook and doing a lot of stuff, and same variable gets repeated. Okay, and so it might actually impact your final result. So if you're doing, I mean, it's good habit to create new small programs notebooks. Okay, and if you face any problem, just execute. There is a reset default graph function there which will reset the default graph. Understood, right?
So what does it mean by assigning to a new graph, or
see what
They're asking about what is the address.
No, yeah, what is the address and what is the purpose of it?
Purpose is so that you can create different graphs. What is the benefit of you create two different graphs? You create two different sessions. Internally, it can make use of different GPUs to execute. It's very independent, right? So graph means the similar diagram that we saw above, right? Nothing like that. Nothing like that. Just that if you create two different graph and each graph has different, computation to, one graph will do some, linear regression. One graph will do some, data pre-processing. This graph will give you output to this parallel processing. Different graphs means parallel execution. Different, different context altogether. Yes, we'll look at. I mean, I'll show. I mean, after the basic stuff, I'll show how to see tensor board and all that. Okay, so we can see that.
So you mean to say when I assign that tf.get default graph, so I can take that single term and I can run it as a different term?
No. Here, this is like I was showing you what is the graph to which this data got added. Okay, this is what a new graph. I'll show how to, how to create object inside this.
Because we are not assigned anything to the graph, right? This show the default graph.
Yeah, the default. This is the default graph, which had all of these.
But earlier we had this also, right? So it will have this hello world also.
Yes.
So what are also the whole? If is the whole program, what are the variables
which I declared so far?
Which is assigned along with TF, then it will show it.
Absolutely. Okay, so there will be a lot of noise around it. So see, if you're understood, right? What is the thing around it? So let's see. Use this one and see how it happens with g dot as default. Okay, so now inside this with code in Python, that's how actually you maintain your sessions. Inside this with code, whatever you write, that will be added to G graph. Exactly. G, that new graph. You can from a variable you can print actually what is the graph number.
No, G is of type graph, right?
Right.
There DEF is of type
tensor.
Multiply
Tensor. Yeah. Okay. So print
a dot standard way of writing code.
TF.
There we have written like TF dot subtract of.
That is a standard way of writing. I mean, if you it supports all the mathematical operation. I mean, when you TF dot something, we'll come across those things. Okay, I just want to show the basic architecture of it. So you can see here, a dot graph is showing you this data, right? This is your G, isn't it? See, this is not getting added to your default graph. Right.
All the old tensors also have come into this G graph or
no, only one thing.
What if you want to have all the old tensors?
Then you have to add them. Here itself you have to you can combine graphs to create a new graph. Add a graph content to the new graph. You can do that. Okay, so you can manipulate. I mean, and more or less, whatever you think, can we do that? Can we? The answer will be yes. Okay, because
everything is possible.
Everything is possible. Yeah. Okay, because for you need things like that. I mean, there is no really a limitation with graphs. I mean, that is the benefit of it. Okay, you can do most of this stuff. So a lot of things we'll discuss. You think we might not, but you can take an assumption. This should work as long as that is logically and intuitive. This should work. Yeah, it is. I mean, the complexity. This complexity makes it very flexible to do complex tasks. Okay, you can see by nature itself, it is very much in line to do deep learning. I mean, you'd find writing deep learning code very easy using TensorFlow because of the graph model. What is deep learning? You have one layer, another layer, and all that, right? You can implement that very well using graphs, right? Right.
So it does also combine with the data visualization to TensorFlow library.
Yes, it is all Tensor board is integrated with it. Okay, that is not for data visualization. That is for graph visualization. Graph vision. For data visualization, you will use the same Python library, like for example, Bokeh, Matplotlib. Okay, any Ratplot. Yeah. You can use. I mean, any other Python library you would be able to use. Okay. Now you have a thing like fetches, which makes your, like, if you want to get all data of all the values. Like as of now, I'm getting data. I'm executing session.run, right, and passing one variable. Okay. Sometimes I want to print all the variables, 5, 10 value variables in one shot. Okay. These are my dependency variables. All the things I want. Okay. So you can make it possible something with something like this. Okay. Let me create. Okay, now say you want all the values. You have a concept called fetches, which is not a keyword. Sorry.
Secondary screen.
Control V, Control V.
Secondary screen.
Oh, that way.
That's not visible only.
Right. That's it. Might be. Okay, you can see here. You can see this is a list, right? You can see this is the list here. Okay, so like it can be dependent on many other things. So you can just pass this as a list here. Okay, it will execute all of them and give you the output like this here. Understood, right? You might have, see, this is a very like you have different parallel execution to have, like training a model. Like internally, it can create parallel execution of it, execute them all in parallel, get the output here like this. Right, fetches. This is how you can pass multiple things here. Again, then you have data types. As you have already guessed. Huh?
List is also data.
List is also. This is a Python data type. It's nothing to do with TensorFlow data type. So we'll now say TensorFlow data type basically. Then,
Fetches is list only. Like list we have all fetches in TensorFlow.
like list. No. The way you pass it is called fetches. This mechanism, like what you did here, this is a any variable name. You can name it anything. Okay, but the concept of passing a list inside session.run is known as fetches, so that it executes all of them and gives you the output.
That's a concept.
Concept, yeah.
But even in so the scale of list also, say different these everything as in the list also. Like we can. So can't we give everything in Python as a list?
You can do that, but here, right, this session.run, earlier we have seen it taking one value only. Okay, all of them. So it will go for its dependency graph and execute that stuff. Here we need, all the values that we have, like E and F are not at all related here, isn't it? Did you notice this? E and F are not at all related. He is related.
Yeah.
So of course you can make it unrelated as well. Like for example, D and say A. Right? You can see here, right? So what happens here? This is like multiple graphs, multiple pipeline getting executed. Right. Okay. So E and F are totally unrelated, but still E will execute and F will execute. They're like doing multiple things in the same shot. Fine, right? That is what fetches is, doing multiple things in the same shot. Fetches. Okay. So let's see some data types. Oh, sorry. Data types. Okay, so now df dot constant. Okay, if you give 4.0 and you want to detype, yeah, df dot float 64. Okay, so here you are mentioning the type here, detype, same as numpy. Your syntax is very same as numpy. Okay, so 3 is equal to this. Okay, then you seems not happy with this. What you can do is you can change the type of it. Df dot cast, pass the data and pass the type df dot. Right, from 64 to 16 you are doing. Then if you want to print the type, d dot. Fine, right?
What are the basic data types?
So if you want to see basic data type, okay, so one is float. You can see all the variations of float, right? Then int, you can see all the varieties of int. I don't think so. String, okay, but and that's very much. So mostly, you know, you will not be dealing with strings. Everything in machine learning library is numbers, right? Okay. So understood this line when I say everything in machine learning, like machine learning is numbers, because if you have a string data, you eventually have to do picturization or convert that into numbers some way or the other. Only then your TensorFlow will do the computation for you. Okay, so more or less you'll be dealing around float and integers.
Can you change float to int also?
Huh?
You can change that to int also. See cast you did, right?
Huh.
Dot float 16, can you get in 32?
I can do that.
Then it will also. But it will show only the 84.5 and then it will show only.
In 16, suppose you do. Okay, so if I execute this now, right, using with session, with df session and all that, you'll see me printing 4, not 0. Tensor ARRAYS and tensor arrays and shapes. Okay, now okay, now I mean, of course, remember one thing, it's not only that you have to always, you can convert any other, like pandas data is there. Pandas is Python's data processing package. You have NumPy, you can convert those data into TensorFlow data, list data into TensorFlow data. All those conversions is possible. Okay. So you can create a suppose you have NumPy array, huh? Import NumPy as NP. Okay, NumPy. Okay, what is the problem with NumPy? NumPy does not allow TensorFlow processing. Of course, it is a NumPy array, does not allow. But you have some data which is in NumPy data format. Now, what you want to do? You want to convert it into TensorFlow object so that you can do TensorFlow machine learning on it, right? So what will you do for that is, okay, d is equal to np dot like
NP or NP?
np. Oh, sorry. np array 1 2 3 4 5 6. Understood, right? So here it will create a NumPy array, and here tf dot constant d, right? It will create a tensor object. Okay, it can take all of this, it can consume all of this data from NumPy object, it is able to consume it. Okay, from there is in NumPy there is something known as linspace. Linspace. So these are like basic linspace. Yeah, linspace. So here, right, you will be giving a starting point. Start is equal to 1.0. Stop is equal to 10.0. Num is equal to 20. What does it mean? It will generate data. D is equal to this. Okay. Now you want to see the data that is generated. Of course, right? It generated some data. These are like sequence generating stuff. So to see the data with f dot. No, it will not random generate. It will generate 20 numbers between 1 and 10. Okay. No. Equally spaced 20 numbers. Understood, right? Linspace. Linspace is it's come from NumPy also. So it is like equally spaced 20 numbers between 1 and 10. Session. Says not done. Oh, session dot run. I'm gonna pass D here. Understood, right? Equally spaced 20 numbers. Between 1 and 10. Okay. Oh, actually, 9 o'clock the other class starts. So your batch is from 7:30 to 9. Is this time fine for you guys? Fine, right? I mean, today it was just, huh?
Today, since we got late.
Today the first time. So, I mean, we'll start at 7:30 to 9 more or less. Okay. And this weekend you will have classes just for this weekend, I guess. Yet to be confirmed. That's okay. I mean, anyway, we're meeting tomorrow. I'll confirm that.
So he told, Nitesh told 4 days.
4 days, like Monday, Tuesday, Thursday, Friday.
Monday, Tuesday, no, the Monday, Tuesday. So there will be Wednesday, there won't be class.
Wednesday there won't be class actually. I mean, all Wednesdays we have, because Saturday, Sunday also there will be classes. Okay. So
per week it will be. So
6 hours. 6 hours, yeah. Fine, right?
Is it possible? Probably we can have, like because sitting now, in that case means it will take 2.5 months.
Yeah, 2 months it will take. You want to add more hours to that. Is it possible to plan on weekend as well? Or weekend you are not sure? Once we can have one class on weekend maybe, right? Like 2-hour class, so that it becomes 8 hours every week.
Yeah.
I'll just give you a confirmation. Somehow we'll manage 8 hours week. I mean, it should be fine, right?
So,
yeah, 8 hours. I mean, usually we do for 6 hours. Okay, but that's okay. We can 8 hours. We can manage. One day will be on weekend. That's the other days. Okay, let's catch up. This will be uploading. This is present in that Zclabs TensorFlow.
Okay.
Zclabs TensorFlow. So I'll create a new repository. In the meantime, github.com/zclabs/TensorFlow. Okay, the initial thing will be present there.
So we will have to take it from the GitHub.
Yeah, or I can do is what I can mail you guys. If you want, I can mail you guys this live. Give me your email ID.
Drop to DR.
Oh, 1 minute. I'm just saying. TO. AJAY. It.
Like going forward, you can have something like on Google Drive, so that like what are the
everything is there in GitHub.
Okay,
GitHub, yeah. I'm just sending it now, but everything is there in GitHub. It's just this URL, github.com/zclabs/TensorFlow. Oh, okay, the other folks are waiting.